the video on numericals on artificial neural network and fuzzy logic. Next problem is an important problem. Construct coherent self-organizing map to cluster the four given vectors. Four vectors are given to you. The number of the clusters that are need to be formed is 2 and assume the initial learning rate or alpha as 0.5. So we initially assume the weights between 0 and 1. Most probably it will be given in your question. If not, then you can assume any random weights between 0 and 1. So the structure of the self-organizing map is something like this. Since we have 4 inputs in single pattern, every pattern has 4 values, 4 digits. So we have 4 neurons and we have 2 clusters that are required to be formed. So output neuron will have 2 output neurons, Y1 and Y2. So this is the pattern. The initial weight WIG, is 0 0.2, 0 0.9, 0 0.4, 0 0.7, 0 0.6, 0 0.5, 0 0.8 and 0.3. Most probably it will be given into your question. If not, then you are supposed to assume the weights. So for the first input pattern, we will calculate the Euclidean distance. Because we have to cluster, the nearest distance to the output neuron will take the value of that neuron. So we calculate the Euclidean distance. D of j is given as summation of wij minus xi the whole square. So d1 will be summation wi1 minus xi the whole square. We are doing it with respect to the first output neuron. So my value wij or wi1 will be 0.2, which is this value, minus 0, which is this value. Similarly, plus 0.4, which is this value, minus 0, which is this value, plus 0.6, which is this value, minus 1, which is this value, and plus 0.8 minus 1, which is this value, the whole square. So this is how I calculate first distance between the first input pattern and the first output neuron. J is equal to 1. So D of 1 is equal to 0.4. With the same pattern, I will calculate with respect to the second output neuron. So I will consider the second weights, which are these, which are 0.9, 0.7, 0.5 and 0.3. So with the same input pattern and the second column of the weight matrix, I'll calculate D2. Now see the value of D1 and D2. D1 is 0.4 and D2 is 2.04. So D1 is lesser, which is the minimum distance, Euclidean distance. Hence for this given pattern X, my X was 0011. For this pattern, the winning cluster is Y1, the first cluster. So I'll allocate this pattern to the first cluster and then I will update the weights on the winning cluster. How do you update the weights on the winning cluster? Wij new. J is 1, I know. So Wi1 new is equal to Wi1 old plus 0.5 xi minus Wi1 old. So I'll have 4 different values of the weights because we have 4 digits in the input pattern. So I have W11 new is equal to W11 old plus 0.5 x1 minus W11 old. So this will give me one value of W11. Similarly, I have W21, W31 and W41. So you'll put all the values and calculate the new weight matrix. So this is my new weight matrix. What we just changed is all these values, the first entire column, because my winning neuron was Y1. So I'll change the first column. Similarly, we can do it for other vectors and update the weights. So for second vector, you will again calculate the Euclidean distance between the first output neuron and the second output neuron. Whichever is the minimum distance, you will update the weights on that neuron. So this is the end of the numerical. Thank you very much.